We're starting a new unit on rational functions, and these are our unit essential questions. Are two quantities inversely proportional if an increase in one corresponds to a decrease in the other? What kind of asymptotes are possible for a rational function? Are a rational expression and its simplified form equivalent? In this section, we're going to use inverse variation and joint and other variations. But first of all, a warm-up. Do you remember inverse variation or direct variation? I'm sorry. Y is equal to kx. You're going to need that in order to do the warm-up. So pause the video and then come back and check your answers. So k is 2. So that means that y is 10. In this one, k is 5, so y would be 15. And on this one, k is 3/10, so y is going to be 6/5 or 1.2. Inverse variation. A function of the form y is equal to k divided by x, k is equal, or x is equal to k divided by y, or xy is equal to k, where k is not equal to 0. So let's look at example 1. Is the relationship between the variables a direct variation, an inverse variation, or neither? Write function models for the direct and inverse variations. So let's look from here to here. It varies inversely. Notice 2 times 0.7 is going to give you 1.4. Each one of these multiplied by each other is going to give you the same amount, 1.4. So y varies inversely with x. This one, neither direct nor inverse. And this one, y varies directly with x. If you multiply x by negative 2.5, then you get y each time. Suppose that x and y vary inversely, and x is equal to 2 when y is equal to 8. Okay, so if it varies inversely, we know that k is equal to x times y. X is 2, y is 8, so we solve this so we can find out what k is. The function that models the inverse, y is equal to k divided by x, we substitute in 16 for k, and this gives us the function that models the inverse variation. Next, we need to graph the function. I set my windows at positive 10 and negative 10. Find y when x is equal to 4. So substitute a 4 in for x, and we know that y is equal to 4. 16 divided by 4 gives us 4. There are combined variations, combines direct and inverse variations in more complicated relationships. And there's joint variation when one quantity varies directly with 2 or more quantities. X varies jointly with x and y. So z is equal to k times x times y. Let's look at z varies jointly with x and y and inversely with w. So we divide kxy by w. Z varies directly with x and inversely with the product wy. So k varies directly with x and inversely with the product of w and y. Suppose z varies directly with x and inversely with y. When x is equal to 8 and y is equal to 2, then z is equal to 12. So write the function that models the variation and find z when x is 4 and y is 6. So first of all, we need to find k. If z varies directly with x and inversely with y, we need to find k. So we know what z is. It's 12 when x is 8 and y is 2. Multiply both sides by 2, then divide both sides by 8. We get k is equal to 3. Now we're going to write the function that models the variation. We know that z is equal to kx over y, and we now know that k is 3. We are to find z when x is 4 and y is 6, so simply substitute in 4 for x and 6 for y. 12 divided by 6 is 2, so z would be 2. Let's look at another problem. Z varies jointly with x and y. When x is equal to 5 and y is equal to 3, then z is equal to 60. So write the function that models the variation and find z when x is equal to 5 and y is equal to 25 hundredths. First of all, we need to find k. It varies jointly with x and y, so z is equal to k x y. We substitute what we were given to begin with. We know that when x is 5 and y is 3, that z is 60. That way we can find k. K is 4. Now write the function that models the variation, substituting a 4 in for k. Now we're going to substitute a 5 in for x and 25 hundredths in for y. Do the multiplication and we find that z is equal to 5. Okay, let's practice this a little more on our own.